Okay, so let's get started with chapter one. We're going to talk about the chemical world. It's just a basic introduction to chemistry from the bare bones. All right. So, for chapter one, the first thing that we're going to talk about is just what chemistry is. So, chemistry at its fundamental kind of essence is the study of chemicals, of course, but specifically the properties and behavior of matter. So, specifically, how matter interacts with itself and how matter is going to interact with um, energy. And we call parts of matter chemicals, basically. A chemical is something that has a distinct composition. And chemicals. So something with a distinct composition, meaning that whatever that thing is made of, it cannot be made of anything else. Otherwise, it is no longer that thing. So, for example, I have a match right here. The tip of this match is made of the chemical phosphorus. This would not be the chemical phosphorus if anything else about it was changed. The number of protons, the number of fundamental particles within that match, if that was changed, it would not be that chemical. And so, underneath the umbrella of chemistry, there are many different varieties, and we're going to go through kind of all of them in this in some way or another. We're going to touch lightly on each one, but let's start by describing the different types. So, to begin, we have physical chemistry. This is the combination of physics and chemistry. So, physical chemistry is when you take the aspects of physics that might be compression or different types of equations and stuff, maybe distances and speeds and stuff, and that would be when you apply them to the fundamental rules of chemistry. And these are going to be, yeah, so the physical properties. This studies the physical properties. Physical properties of chemistry. Organic chemistry is one that you might have heard of before. It's probably the scariest sound one because this is the one that people take the most in higher level chemistry classes, even if they are not going to pursue chemistry as sort of a goal. So, organic chemistry is the study of interactions between chemicals that mainly contain hydrogen and carbon. And carbon. I apologize for my handwriting. Sometimes it's really good, sometimes it's kind of bad. Basically, organic chemistry is so useful and required in many disciplines because it forms the foundation of biology, pharmacology. Oop, that's not how you spell that. Pharmacology, any kind of doctor type thing that you will be doing, like if you were to go to med school, organic chemistry is going to be the basis. And that's because we are organic substances, right? If you've ever heard the term that we're carbon-based life forms, that is how we are going to be interacting with matter in the most part. So organic chemistry is usually organic molecules. And those are going to be or is completely organic molecules, and those are going to be the things that we interact with. So if you're going into something like the medical field, organic chemistry is going to be important for you. Now, what I studied um, was inorganic chemistry. So, organic chemistry is specifically carbon and hydrogen. That's the most of it. But inorganic chemistry is, in a way, the opposite of organic chemistry. Um, it deals with the entire rest of the periodic table. So that's everything else. Everything else is on the periodic table besides carbon and hydrogen, and nitrogen, oxygen, phosphorus. Those things are going to mostly be metals, but to some degree, that is going to be that's what I studied. I specifically studied the F elements, which I'll show you them. I'm sure I'll talk about them quite a bit during this. Um, and yeah, but we also do uh, sometimes use carbon and hydrogen. So those are the symbols for carbon and hydrogen. Hydrogen. We'll get to those eventually. Sometimes they use carbon and hydrogen. In fact, quite often they do. Analytical chemistry. This is where you get to use all the fancy equipment. Oop. So fancy equipment. You also get to uh, basically do the tests. So, any kind of testing that you are going, if you were to, let's say, go into forensic science, you would want to do more analytical chemistry. So, forensics, because this is going to tell you the behaviors of those atoms. It's kind of going to it's like being a photographer of the atom in a way. Like you're going to be able to see what it is like in its natural environment by running different types of tests on it. Forensics is definitely going to be using that. And then purity assessments. Also, chemical industry. This is something that would be big for analytical chemists. And then finally, we have theoretical chemistry. So this is the stuff that can get kind of mind-boggly. This is usually these days it's computational. So you would still need to know what to put into the computer, but the computer's going to do a lot of the work there. It's going to really it's a lot of calculations. Um, it also is a way to provide explanations for specific things that you might see. So, like for your observations, but it also can predict behaviors. So this is to basically maybe a wet chemist, which is somebody who works in a laboratory, would do an experiment and not be able to figure out what happened. So they would go to a theoretical chemist and they would say, "Can you tell me what happened?" And they would run some calculations, say, "There's a likelihood that this happened in your chemistry." Um, so yeah, so those are the main types of chemistry. There are many, many different subgenres within this. For example, I did organometallic chemistry, which is a mixture of both inorganic and organic chemistry. There's all types though. Okay, so all of these, though, what they all have in common, in any place in science, is going to employ the scientific method. So the scientific method is a way to learn that emphasizes observation. The way that it would work is like this. Um, let's say that you first observe something. You would observe that, let's say that if you just place something on the ground, it's going to stay at rest until you change it, until something changes. So an observation is one of two things. Either it's a measurement, so that would be something that has a number associated with it, or that you would use equipment to figure it out, or it would be um, data, something you experienced. So something experienced with the five senses. So something you can taste, feel, smell, hear, and the other one that I forget, that would be see. Um, that would be something that is an observation. A hypothesis is going to be the educated guess that you make based on what you observe. So this would be an educated guess based on your observation. So this would be like um, you see something on the ground and you say, "Oh, it's not moving," for example. I wonder if this will work. My cat right there is not moving because the cat is magnetized to the ground. All right. That would be a hypothesis that you would make um, based on your observation. Cat's not moving, must be stuck there by a magnet. All right. Um, Now the experiment you would do is going to test that hypothesis. So this tests hypothesis. um, in controlled settings. So let's say that I put the cat on the ground, I cleared everything out of the room, and I didn't do anything to it, so it's just a cat in its natural habitat. And then I used some kind of piece of metal around it to see if that thing also would be magnetized. That would test my hypothesis that the cat was stuck there via magnetism or something like that. So test hypothesis in controlled settings. Um, you would really only ever change one variable at a time if you were going to do multiple experiments, right? So maybe put a radio near it to see if that interferes with the magnets, or I don't know, something educated is what you would do next. That wouldn't be educated, I don't think, but who cares? This is a ridiculous example anyway. Out of this, you would then get a scientific law. So your scientific law, as is shown here, such as Newton's laws, is that an object stays at rest, or if it is in motion, it will stay in motion unless acted upon by an outside force at the same speed, unless acted upon an outside force. So this is just basically a brief statement um, a brief statement that summarizes past observations and one that can predict future ones. So laws you would be able to prove, right? Like if you said that an object at rest stays at rest, that would be true for multiple different objects. It's not just the thing that you observe staying at rest. And so I could conclude from my cat not going anywhere that the object is at rest, right? A theory is basically a detailed version of um, a hypothesis that's been updated since you have done your experiments using evidence. Using evidence. So it might not exactly be a one-to-one with your hypothesis and your theory. In fact, it's usually not going to be. Okay. So that's it for chapter one. I'll see you in chapter two.